Section 6.2 is on rational exponents, meaning fractional exponents. We will use the following exponent rule. If you have base A raised to a fractional exponent, the denominator is always your index, and then the numerator is the exponent we raise A to, or the exponent we can raise the whole radical to. These two forms are equivalent and we can switch between the two depending on the problem. What we want to do for the first three examples is to simplify. Let's start with part A. Using our exponent rule, I know that this is a square root. The index is 2. So what we can do is first rewrite the problem to make the exponent positive. Using the exponent rules from the previous section, we can write 1 over 121 to the positive 1/2 power. And then I know that this is the same as 1 over square root of 121. Square root of 121 is 11, and we have our final answer. Example B. We also have a negative exponent and, in addition, a negative base. The negative base doesn't really change. We just have to rewrite the problem to make the exponent positive first. So we can write 1 over negative 216 to the positive 1/3 power. Since the denominator is 3, I know that this will change into a cube root. 1 over cube root of negative 216 to the 1st power. We don't have to write 1 here, but it is to the 1st power since the numerator here is 1. We just simplify. Cube root of negative 216 is negative 6. And we have example C. We're going to apply the exponent rule here as well. One thing to notice is that our fractional exponent has 2 in the numerator. So just slightly different compared to the first two examples, which just had a 1. And also our base is a fraction. But that's okay, we're just going to apply the same rule. So this is a cube root 27 over 64, and we're going to put exponent of 2 on the outside because it's easier to square at the end rather than at the beginning. Let's take the cube root first. Cube root of 27 is 3, and cube root of 64 is 4. Then we square 9 over 16 is our final answer. Let's take a look at one more example for this section. This is toward the end of the problems in your text. For this last example, we have to remember the exponent rules that we learned in section 6.1. Those exponent rules should be memorized because you need them for your test. So the first thing we want to do is use the power rule where we take 1/2 and we multiply with all the exponents on the inside of the parentheses. Please notice that 25 has an exponent of 1 and so does 2. So the first thing is use the power rule. 25 to the 1/2 power. A squared. B to the negative 1/2 power. 2 to the 3rd. A to the 3/5. B to the 9/5. All right, what we did earlier, just a few minutes ago, 25 to the 1/2 power is equivalent to square root of 25. So I could calculate that. 2 to the 3rd we could calculate. And then for A, since we have the same base, we're going to use the quotient rule and subtract our exponents. The same thing applies for B. Since we have the same base, we would subtract these two exponents. Just need to be careful because the exponents are fractions. Let's start with the first part, 25, square root of 25. I know that's 5. And then 2 to the 3rd is 8. So we have that. The next thing is that we have to use the quotient rule. So we write our base and we subtract our exponents. 2 minus 3/5. And then we have B, negative 1/2 minus 9/5. Off to the side here, let's do our calculations. 2/1 minus 3/5. You need to get a common denominator, which in this case is 5. And so we have to multiply 2/1 by 5/5. So when you do that, you get 10/5 minus 3/5. That gives us 7/5. That's the exponent for A. Let's do the subtraction for these two. Negative 1/2 minus 9/5. The common denominator between 2 and 5 is 10. And so we have to multiply the first fraction by 5, the second fraction by 2. And that's going to give us negative 5 minus 18/10. And if we calculate that, we're going to get negative 23/10. Now that we have our exponents, let's go back to the problem. We have 5/8, A to the 7/5 power, B to the negative 23/10. One last thing you want to do is write your final answer with positive exponents, which means B needs to move to the denominator. A stays in the numerator. Our final answer is So that's it for this section. I highly recommend you start memorizing the exponent rules, the ones from 6.1 and 6.2. You need those to do all of these exponent problems for your test.